B.Sc Year 3 Mathematics, Unit-Wise Summary. Paper 1, Numerical Method and Scientific Computation. Root Finding Methods, numerical algorithms used to find the roots of a given equation. Interpolation and extrapolation, techniques used to estimate values between known data points or beyond the range of the data. Numerical differentiation and integration, numerical algorithms used to approximate derivatives and integrals of functions. Numerical solution of differential equations, numerical algorithms used to solve differential equations using methods such as Euler's method and Runge-Kutta method. Least squares approximation, a method for finding the best fit line or curve for a set of data points. Numerical linear algebra, the study of algorithms for solving systems of linear equations, eigenvalue problems, and singular value decomposition. Error analysis, the study of how errors in numerical computations affect the accuracy of the results. Paper 2a, Discrete Mathematics. Sets, relations, and functions, the fundamental concepts of discrete mathematics used to describe and analyze discrete structures. Propositional logic, the study of logical statements and their connectives, and the use of truth tables to determine their truth values. Predicate logic and quantifiers, an extension of propositional logic that introduces variables and quantifiers to make statements about objects and their properties. Combinatorics and counting, the study of how to count and enumerate different arrangements and combinations of objects. Graph theory, the study of graphs and their properties, such as connectivity, coloring, and planarity. Trees and forests, special types of graphs with specific properties, including rooted trees, binary trees, and spanning trees. Discrete probability, the study of probability in the context of discrete structures, such as counting problems and random graphs. Number theory, the study of integers and their properties, including divisibility, prime numbers, modular arithmetic, and Diophantine equations. Paper 2b, Probability and Statistics. Probability axioms and rules, the mathematical foundations of probability, including probability axioms, conditional probability, and Bayes' theorem. Discrete and continuous random variables, types of random variables that can take on either discrete or continuous values. Probability distributions, mathematical functions that describe the probabilities of different outcomes of a random variable, including the binomial, Poisson, normal, and exponential distributions. Sampling distributions and central limit theorem, the properties of distributions of sample means and proportions. And the central limit theorem that describes their normal distribution under certain conditions. Confidence intervals and hypothesis testing, statistical techniques used to infer population parameters from sample statistics and test hypotheses about them. Simple linear regression and correlation, techniques used to model the relationship between two variables and make predictions based on that relationship. Multiple regression and model selection, techniques used to model the relationship between multiple variables and select the best model for a given dataset. Bayesian statistics, a framework for statistical inference that uses probability distributions to express uncertainty and update beliefs based on new information. Paper 2c, Integral Transform. Fourier series, a representation of periodic functions as an infinite sum of sines and cosines. Fourier transform, a transformation that decomposes a signal into its frequency components. Laplace transform, a transformation that converts a differential equation into an algebraic equation, making it easier to solve. Z-transform, a discrete version of the Laplace transform used in the analysis of discrete time systems. Applications of integral transforms in solving differential equations, the use of integral transforms to solve differential equations in physics, engineering, and other fields. Discrete Fourier transform, a discrete version of the Fourier transform used to analyze digital signals and images. Fast Fourier transform, an efficient algorithm for computing the discrete Fourier transform. Wavelets.